Hello, today we are going to be dealing with 7172 day 2 exponential modeling, which is just a continuation of the last examples, except now we're going to use this number E. Number E, well, it's called Euler's number, and that number is about 2.72. There is a button on your calculator. I will show you in a minute where it's at. This is interest compounded continuously. This is the formula. A equals P times E raised to the RT. P is still principal. E is this Euler's number here. R is rate, and T is time. So all you gotta do is plug it in and go to your calculator, and again, I will show you that in a second. All right, so let's change the color a little bit here. You deposit $1,000 into account that pays 8% annual interest, compounded continuously. What is the balance after 2 years? This is your P, this is your R, the compound continuously makes it an E, and this is your time. So your equation, A equals 1,000 E to the 0.08, that's this divided by 100, okay, times the amount 2. Okay, let's go to our calculator and show you where this is. All right, we're going to go to my calculator on my screen. Hang on. That's the TI-80, that's the Calculate 84. And I'll press it. It is second and then ln. Okay, I'll do it again. Second, ln. Right there. Hitting it over and over again. See, it's white now. That's the thing right here. Okay, right next to 4. There's also another E, and I'll hold it down so it turns, well, it's black now, but I'm turning it here. It's right here on the division. So if I press second and I hit that, you'll see E. But the one on ln, the one I'm holding down now here to turn white, next to 4, that'll give you the caret, or the exponent for yourself. Okay, so 1,000, this is all you have to do. All right, 1,000, and then second, E. It's being raised already, so that's 0.08 times 2. I press enter, $1,173.51. So let's write that down. $1,173.51. All right, pretty basic enough. All right, you ready to try another one? Here we go. For the years 1972 to 1998, the number S of the species of an endangered S as species of an endangered species list can be modeled by this form here. Oh, sorry. I'm trying to get my. Nope. Nope. There it is. Okay, so this is our equation. They gave it to us already. Don't even have to think about it. T is the numbers since 1972. What is the number of endangered species in 1972? So if I talk about this here, that's S equals 119 E to the 0.0917. And what is T? Well, since 1972, there are no years. So what's the answer? Well, hopefully you know it's 119 species, because anything raised to the 0 is 1. Don't believe me? Second, E to the 0 is 1. There it is. All right. Now, down here, estimate when the number of endangered species will be 1,000. All right, a lot of you had questions about this. When we're talking about prediction, estimate the number of endangered species, they want to know when, which is T. It says when. All right. So that means that it's 1,000 equals 119 E to the 0.0917, and I'll put an X here to show you that we are going to put in our calculator. It's the T here, guys, but this is just X. So that means on Y1, we're going to put 1,000. On Y2, we're going to put 119 e to the 0.0917 x. Okay, hang on, I gotta change that. I gotta make this, sorry. Here. Rewrite this again because that's just way too messy, and I make sure I'm right. Y2 equals 119e to the point 0917x. We are going to find this intersection, okay? A lot of you were also asking, well, how do I know what to put my max? My max has to be bigger than this number. Y1 is 1,000. It's got to be bigger than that number. So that means I'm going to probably put like 1,500. So let me get to my calculator and show you. But these two things are going in the calculator. All right, we'll clear this up. Y equals. All right, so 1,000 was Y1. Y2 is going to be 119 times E to the 0.0917 X. All right, let's go change our window. Window, there it is. So I'm not really worried about what X max and min right now. But my Y max, this one here, has to be bigger than 1,000. So I'm going to go 1,500, and I'm just going to press graph and see what I see. Okay, notice over to your right here, it does not intersect, which means my X has to be bigger. So let's go and make my X bigger. Now I'm guessing here what my X is going to be. So I'm just going to delete this, and I'm going to put, I don't know, 30, I don't know, whatever, and press graph. Okay, it intersected. Good. So there it is, the intersection. So second, trace 5, move the cursor over to the intersection, and if you're using a calculator that's not on this computer or anything, you hit enter 3 times, otherwise you can enter twice. It says intersection is 23.24, okay? 23.24, so 23.2 years. All right, so that means X here is 23.2 years. I'll circle it so we know that's the answer. And that's it there. Okay, so this went in the calculator. Sorry for the slam here, but Y1, Y2, right? We found the intersection. We noticed that it didn't cross, so we made X max bigger. I guessed and right 30. You probably could have got it. Well, you could have got it at 25. All right. All right. I only have one more example today, and it's about half-life. Half-life is mostly about decaying and things disappearing, carbon dating, stuff like that. Half-life is the time it takes for half the sample to change its state. So a lot of times decaying, you could look up a decaying animal on the side of the road and it takes half its time. How long does it take? A lot of it's carbon dating. A lot of it has to do with elements. So here's your formula. So let's go get my thing. Here's the formula here, okay? Y equals A, which is your initial amount, always your initial amount A. 1/2, this is constant, okay? And then this here is actually a fraction. So I'm going to rewrite this just so you can see what it looks like. And it's like this, X over half-life, okay? HL, half-life, it's a fraction. So it says, suppose here that the half-life of the substance is 20 days, and there's 5 grams present initially. How much of the substance would be left after 64 days? So Y equals the initial amount, 5 grams. Hang on, I'm sorry, let me start this over because it doesn't look good. Let me try it again. Okay. Y equals the initial amount is 5 grams. The half ain't changing. And then it says X over half-life time. All right, so that's what we need. X is the 64 over what they said it took 20 days to get rid of it. All right, so what you're going to do is you're going to put this in the calculator exactly as you see it. If you want, I will do it for you too. All right, second quit. We had 5 grams times a half. All right, I got to come out of it, raise it up to 64 divided by 20. I don't have to reduce anything. 0.54 grams. So that's it, 0.54 grams. 0.54 grams. And that is it for today. That is 7172 day 2. That is dealing with Euler's number, which is that number E in your calculator, and half-life. All right, let me know if you have any questions, and we'll see you next time.